We will continue one more video here, that is order of reaction. What is order of reactions, sir? Simply, there are various types of reactions are there. Elementary reaction is also called simple reaction. The chemical reaction which is completed in single step is called elementary reaction. It is also called simple reactions. The chemical reaction which is completed more than single step, more than one step, is called complex reactions. The order is defined. Order is a experimental data. What is the statement of order, sir? The sum of powers of concentration terms of reactant in the rate equation or rate law is called order of the reaction. The sum of the powers of the concentration terms of the reactants in the rate equation. It is called order of the reaction. For example, if you take here, the order of the reaction can be determined by experimental methods only. The order of the reaction can be determined by experimental methods only. The order may be 0 or positive or negative, even fractional also, but not in decimal form. But not in decimals. For example, now I am taking here A gives rise to product is there. What is the rate equation here? R is equal to K into concentration A power 1. Order is equal to denoted to be symbol N. Power is equal to 1. The sum of powers of concentration term is equal to 1 is called zero order reaction. If you take 2A gives rise to product, R is equal to K into concentration of A42. Here N is equal to 2. The sum of the powers of the concentration terms of the reactant, here 0 to take. The sum of powers of concentration term, if you take here only one, no, first order. The sum of the powers of the concentration terms of the reactant is equal to 1 is called first order reaction. 2A gives rise to product, R is equal to K into concentration of A. This is called second order. If you take 3A, gives rise to product, R is equal to K into concentration A power 3. The sum of the powers of the concentration terms of the reactant is called order of the reaction. We take some more example. Only for elementary reaction, this one. For elementary or simple reactions. For elementary or simple reactions, the sum of the powers of the concentration terms of the reactants. For example, if you take here, XA plus YB plus NC gives rise to product is there. How to determine the rate, sir? The rate of reaction is directly proportional to the product of concentration of A, B, C. A number of moles X, Y, A, N. Or if you take Z also here, the sum of the powers is equal to X plus Y plus Z. If you take one more example, 2A plus B gives rise to product. R is equal to K into concentration of A power 2, B power 1. N is equal to sum of the powers of the concentration term is equal to 3. If you take 1 by 2 A moles, 3 by 2 B moles, B reactant gives rise to product. R is equal to K into A power 1 by 2, concentration of B power 3 by 2, N is equal to sum of the powers. 1 by 2 plus 3 by 2 is equal to 4 by 2 is equal to 2 only. Second order reaction. This is second order reaction. I hope it is clear. We take one more equation. Three by 2 moles of A reactant to 1 by 2 moles of one by 3 moles of B reactant to form product. What is the equation here? R rate equation. R is equal to K into concentration of A power 3, A power 3 by 2, concentration of B power 1 by 3. N is equal to 3 by 2 plus 1 by 3. By taking LCM is 6. 9 plus 2 is equal to 11 by, this is the fraction. 1 by 2 A moles, 4 by 5 B moles. Or if you take one more example, 1 minute. Now I am taking one more example here. Gives rise to product. N is equal to 5 plus 8 by 10 is equal to 13 fractional orders. These are the various examples. If you take the sum of the powers of the concentration term is in negative order. The sum of the powers of the concentration term is equal to 0 order. The sum of powers of the concentration terms of the reactant is equal to fractional value fractional order. Like that. Some important examples here. Some important example illustrating different studies of order and rate expressions. You can observe here some important examples. That is based on the complex reaction. What is the complex reaction? The reaction which is completed more than single step, more than one step. It is depending upon the reaction mechanism. Reaction mechanism. That means here, now I am taking here, okay, what is reaction mechanism, sir? Okay, reaction mechanism is nothing but simply the sequence step by step process of chemical reaction is called reaction mechanism. How to define the reaction mechanism, or that is another concepts. Simply the detailed step by step description of any chemical reaction is called reaction mechanism. For example, now I am taking one reactions here. N2O5 which decomposes to N2O4 plus half O2. Now I am taking balancing purpose. 2N2O5 gives rise to, not N2O4 here, NO2. 4NO2 plus O2 only. You can observe here there are 2 moles are there, but it is depending upon the mechanism. The order of the reaction is R is equal to K into concentration of N2O5 1 only. That means your order is equal to first order only. Like that, if you take one more example, ozone converted into oxygen. R is equal to K into concentration with respect to oxygen to respect to ozone minus 1. Order with respect to oxygen is equal to second order. Order with respect to ozone negative order. Experimentally proved. How, sir? It is depending upon the mechanism. If you take overall order means 2 minus 1 is equal to 1 only. If you take another example, NO plus CO, that means nitrogen dioxide, gives rise to NO plus CO2. R is equal to K into concentration of NO2, concentration of CO. For here 1, here 0. The sum of the powers is equal to 1 only. Not 1 here, yet 2. The order with respect to NO2 to NO2 is equal to 2. Order with respect to CO is equal to 0. And another example is acetaldehyde decomposes to CH3CHO gives rise to CHO. K into concentration of CH3CHO power 3 by 2. That means here order is equal to derived fractional value. How to decide these values, sir? How to determine, sir? By experimental conditions. It is depending on the reaction mechanism only. Depending on the reaction mechanism. And also here, from all the above examples, it is clearly clear that there is no relation between stoichiometry of reaction and as well as a order of reaction. Order is always determined experimental data, experimental fixed. The Wright law is expression normally involves reactants, but it may also involve catalyst also, but not product concentration. Does not depends on the product concentration. On changing the stoichiometric reaction, reaction rate of reaction rate constant changes, but rate of reaction for particular substance remains same. Only simple or elementary reaction, step reaction, order of reaction is equal to their stoichiometric coefficient reaction, stoichiometric coefficient of the reactants. If you take various complex reactions or complex reaction, the order is depends upon the reaction mechanism. The order of reaction is also changes with the conditions under which reaction is performed. Okay, these are the introduction part of order of the reaction. Next class we will continue types of orders.